Hi, this is Mrs. Doris. This is lesson 2-10 entitled Change Represented as a Percent. Our objective is that you will be able to find percent change and also that you can find the relative error in linear and nonlinear measurements. This is a valuable tool in many real-life problems. All right, so some vocabulary. First of all, percent change. This expresses an amount of change as a percent of the original amount. A percent increase occurs if the new amount is greater than the original amount, and a percent decrease occurs if the new amount is less than the original amount. Relative error is the ratio of the absolute value of the difference of a measured or estimated value and an actual value compared to the actual value. I'll demonstrate this and we'll write a formula when we solve a problem about this. And percent error is the relative error expressed as a percent. Problem 1, finding a percent decrease. The average monthly precipitation for Chicago, Illinois peaks in June at 4 1/10 inches. The average monthly precipitation in December is 2 8/10 inches. What is the percent of decrease from June to December? All right, so percent change is the amount of change over the original amount. All right, so here we go. The amount of change is going to be 4.1 minus 2.8. In other words, the change is finding the difference between the two amounts of precipitation. Then we're going to divide that by the original amount. Well, they want to know the percent of decrease from June. Sorry for that interruption. All right, so the original amount is usually contained where you see the word from, they want from June. So June was 4.1. All right, so 4.1 minus 2.8 is 1.3, and we're going to divide 1.3 by 4.1. All right, and it's not going to come out even. 1.3 divided by 4.1 is 0.317, and it goes on. So we're going to, this amount is represented as a decimal. So to change it to a percent, we need to multiply it by 100, which means moving the decimal over 2 places. And so it's approximately 31.7%. Or rounded to the nearest percent, if the problem requested you to round it, it would be 32%. All right, problem 2, finding a percent increase. In 1 year, the toll for passenger cars to use a tunnel rose from $3 to $3.50. What was the percent of increase? All right, well, the first thing that we have to do is find the difference, and you can probably do that without doing this. It went up 50 cents. So that is the amount of our change, is 50 cents. The original amount is the from number, 3. So we want to divide 50 cents by 3. And we get 0.16, and the 6 is repeating. So changing this to a percent, moving the decimal point over a couple of places, it would be 16.6 repeating percent, or written as a fraction, 16 2/3%. All right? Okay, problem 3. Find the percent of error. You think that the distance between your house and a friend's house is 5.5 miles. The actual distance is 4.75 miles. What is the percent of error in your estimation? All right, well, remember that the relative error was defined as the absolute value of the difference in the estimated, let me just write it out, the estimated minus the actual, all divided by the actual. Okay, compared to that. So, here we go. Our estimated was 5.5. The actual distance is 4.75. And we're going to divide that by the actual of 4.75. All right, well, 5.5 minus 4.75, we actually get a positive number, so we don't have to worry about the absolute value. And we're going to divide that by 4.75. So 0.75 divided by 4.75, the actual distance is 0.15, and I'm going to go ahead and round it to 8. So expressing this as a percent, again, I move the decimal point over 2 places, and it would be 15.8% is the error in our estimation. All right, problem 4, finding minimum and maximum dimensions. The most any measurement can be off is by 1/2 of the unit used in measuring. All right, so we have a student's height is measured as 66 inches to the nearest inch. All right, so inch is our unit of measurement. What are the student's minimum and maximum possible heights? All right, now let's go back to the definition. The most any measurement can be off is by 1/2 of the unit of measurement. So if we're measuring to the nearest inch, half of that would be a 1/2 an inch. So the minimum would be 66 minus 1/2 an inch, which would be 65.5 inches tall. The maximum would be 66 plus that 1/2 inch, which would be 66.5 inches tall. So minimum height 65 and 5/10 inches, maximum height 66 and 5/10 inches. Problem 5, finding the greatest possible percent error. Now this requires several steps, so don't be daunted by it, but it is a rather complicated type of problem. A gift box with measurements of length 12 inches, width 6 inches, and height 5 inches has been measured to the nearest 1/2 inch. All right, I'm going to underline that because that will be important. What is the greatest possible percent error in calculating the volume of the gift box? All right, so first of all, let's come up with the measured volume. Remember, volume is length times width times height. So in this case, our volume would be equal to the length of 12 times the width of 6 and the height of 5. So our volume is 12 times 30 would be 360, and that would be inches cubed. Okay? Now, let's figure the minimum volume, and then we'll figure the maximum volume. Okay, now remember that to find the relative error, it's half of what we're measuring to. So if we're measuring to the nearest half inch, it could be off by a quarter of an inch either lower or a quarter of an inch higher. So 12 inches as a minimum length would be 11.75. The width, 6 inches, take off a quarter of an inch, would be 5.75 inches. And the height of 5 inches, take off a quarter of an inch, would be 4.75. All right, so let's multiply all this together to find our volume. 11.75 times 5.75 times 4.75. And we get 320 point, and I'm going to round this off, 92, and that would be inches cubed. All right, so there's the minimum volume. Now let's find the maximum volume. If when we measured it was actually a little longer. All right, so 12 inches, we'll add that quarter of an inch on. So we have 12 and 0.25 times 6.25, adding on a quarter of an inch to the width and adding on a quarter of an inch to the height, 5.25. All right, let's multiply this together. 12.25 times 6.25 times 5.25. All right, and I get a maximum volume of 401.95, and again I'm going to round it off, and that's inches cubed. Notice there's quite a bit of difference between the minimum volume and the maximum volume. All right, well, what we need to do now is find the difference between our minimum volume and our measured volume. So I'm going to take, and I'm going to take the larger minus the smaller. So if it's minimum, I'm going to take 360 minus 320.92. If it's the maximum, of course, which is larger, we'll take the 401.95 minus the measured, which was 360. And let's see what we get. All right, for the minimum, 360 minus 320.92 is 39.08, and the maximum, 401.95 minus the 360. Got to do that again, I made a mistake, is 41.95. All right, so the question is, what is the greatest possible percent of error? So between these two amounts, we pick the larger amount, and the larger amount would be 41.95. Then, to find our percent error, we divide by the measured volume, 360. All right, so 41.95 divided by 360 is, and again, this is approximate, 0.1165. Since it's a 5, we'll increase that 6 to a 7. All right, so, or as a percent, moving my decimal point over 2 places, I would have 11.7%, and that is the greatest possible error in calculating the volume. All right. If you have any questions or if you feel like you've got the idea of it, and there's a good examples in your book if you need something there to follow as well, then you may begin work on the exercises on page 148 and 149, problems 7 through 29, the odds, and also number 37. If you need some more examples, then I have a few more here for you. Number 1, running. Last year, an athlete's average time to run a mile was 6 minutes 13 seconds. This year, the athlete's average time is 6 minutes 5 seconds. What is the percent of decrease? Okay, well, you'll notice we're actually dealing with two different measurements here, minutes and seconds. So I would highly recommend that we change them to, you're going to have to change to the smallest unit possible, which would be seconds. All right, so 6 minutes, 13 seconds is equivalent to how many seconds? All right, well, each minute has 60 seconds, so in 6 minutes, that would be 360 seconds, plus 13 would be 373 seconds. 6 minutes and 5 seconds would be 360 plus 5, or 365 seconds. All right, so now we can figure our percent of decrease. All right, so what we do is we find the difference between our seconds. 373 minus 365. And we're going to divide it by the original, which would have been last year. So divide by 373. Okay, so here we go. 373 minus 365 is 8. Okay, which we could actually have solved that right here just taking 13 minus 5, but no big deal. So 8 seconds, and we want to divide it by the original, and this is where we would need our 373. Okay, so 8 divided by 373 is 0.02, and I'll just round it off at the hundreds. What is the percent of decrease? Move your decimal point over 2 places, and it would be a 2% decrease. It's a little over 2%, but not much. All right, number 2, cars. A used car dealership buys a car for $2,800 and then sells it for $4,500. What is the percent increase? Okay, first of all, we want to find the difference, or the amount of change. 4,500 minus the 2,800. And then we want to divide it by the original amount. Well, the original amount would have been what they bought it for. So we're going to divide by 2,800. Okay, 4,500 minus 2,800 is 1,700 divided by 2,800. And we get 0.60714. It keeps going. But moving my decimal point over 2 places, it would be 60.7%, or to the nearest percent, 61%. Okay, if you are asked to go to the nearest percent. Number 3, horses. A veterinarian measures a horse to be 7 5/10 feet tall at the shoulder to the nearest half foot. What are the minimum and maximum possible heights of the horse? Okay, so he's been measured to the nearest half foot. So the difference is half of that measurement. Half of a foot would be 1/4 of a foot. So that would be 0.25. So if the horse is 7.5 and I subtract 0.25, at a minimum, the horse would be 7.25, and that would be feet tall. At a maximum, starting at the measured height is 7.5, we would add the 0.25. And so at the tallest, the horse would be 7 7/75 feet tall. All right, so minimum and maximum possible heights. Remember, it's half of the unit that you have measured to. Number 4, determine whether each situation involves a percent of increase or a percent decrease. A hat that originally cost $12 sold for $9. We are going down here, so this would be a decrease. Part B, you buy a CD for $10 and sell it for $8. That would also be a decrease. C, a store buys glasses wholesale for $2 per glass. The store sells them for $4.50 per glass. So since it is increasing, this would be an increase. All right, if you have any questions, please see me. Otherwise, happy solving.